All right, this video we're going to talk about the strengths of acids and bases, how strong an acid and a base is. So first of all, let's talk about the strength of an acid. So the definition of a strong acid is that it ionizes completely. So a strong acid, it ionizes completely. So when it ionizes completely, here's what happens to it. So we have a hydrochloric acid, for example. When hydrochloric acid is put in water, it splits apart and it goes into a hydrogen ion and a chloride ion. And it goes over to the right, it splits apart and it stays apart. That means it ionizes completely. Okay, weak acids don't. So weak acids, they ionize only partially. So they don't ionize all the way. They only ionize partially. So for example, a good example of this is carbonic acid, H2CO3. Now, if you notice, I'm going to draw the arrows a little bit different. That way and then that way. So when it ionizes into a hydrogen ion and a hydrogen carbonate ion. Okay, so what it'll do is it'll split apart and then it'll turn and it'll come back together. So it doesn't stay apart. It goes apart and then it comes back together. So you don't have as many hydrogen ions in the solution all the time, and that's what we call a weak acid. Now, how do you tell the difference between a strong acid and a weak acid? Well, a strong acid is, you look on page 645 and there's a list. Okay, there's a list of strong acids. It's not a very long list. It is hydrochloric acid, perchloric acid, nitric acid, hydroiodic acid, and sulfuric acid. So that's our list of strong acids, and basically we're going to say every other acid is a weak acid. And also on page 645 it gives you some examples of some weak acids too. So this is our list of strong acids and everything else a weak acid. So when we talk about acid-base strength, that's what it means. So the more hydrogen ions it will split apart and stay apart, the stronger it is. If it goes one way and runs back the other way, that's what we call a weak acid. Now with bases, let's talk about what a strong base is. So it's a lot the same as a strong acid, to where a base will split apart and it stays apart. So a strong base, instead of ionize, we say that the base dissociates. So the base will dissociate entirely. So example of a strong base is sodium hydroxide. Sodium hydroxide splits apart into a sodium ion and a hydroxide ion, and they stay apart. That hydroxide doesn't go back and forth, and that's what we call a strong base. Okay, a weak base. So a weak base. A weak base, what it'll do is it will split apart and then it'll go back together. So it ionizes partially, just like the acid. So it ionizes only partially. Examples of weak bases. Let's see, trying to think of one. Let's do CH3 NH2. So it'll go apart, it'll turn around, and it's going to come back together. It splits up into CH3 NH3 plus it has an OH on it. So what it's going to do is it's going to split apart and then it's going to come back together. Just like the acids did, it split apart and then it would come back together. Now, How do you tell the difference between a strong acid and a strong base? So a strong base, basically, here's the kind of the really short, easy way to do it. If you have an, alkali metal, oh, I totally slaughtered that word, alkali metal, or an alkaline earth metal, plus an OH, it's a strong acid. So example, calcium hydroxide. Okay, it's a strong base. Lithium hydroxide, sodium hydroxide. Okay, so all those, these are strontium hydroxide. All these are going to be strong bases. Anything else, if it's not an alkali metal or an alkaline earth metal plus an OH, then it's going to be a weak base. And that's how you tell the difference between a strong base and a weak base.